let me start out for the sine wave and cosine wave, either one. Normally, people don't go, oh, square root of 2 over 2 and know exactly what that means or where that should be placed on the graph. I'm going to use decimals today, so obviously you guys know that a half is 0.5, but I'm going to write the other two as decimals also. So root 2 over 2 as a decimal, I'm going to go 3 decimal places here, is 0.707, so real close to 0.7, and the root 3 over 2 as a decimal is 0.866, so really close to 0.9. And it's not going to be perfect. We're going to estimate kind of as we go along here. So what I'm going to do first with you guys is the sine wave. So essentially what's going on here in the graph is the x-coordinate of my point is going to be the angle measurement, so in radians, and then my y-coordinate of the point is going to be the sine. So I'm going to just grab my unit circle just really quickly. So the reason I wrote those values down, as you go around the unit circle, I'm just going to grab these y values and put them into the table. So I'm going to start, they're all going to be positive until I get around to pi, and then once we start going down here, then it's going to end up with negative y-coordinates. So it's going to be these same decimals, but we're just going to have positives and negatives. Okay, so the sine of 0, if I look at my beautiful unit circle, the y-coordinate of that angle is actually 0. Okay, now pi over 6 is going to be your 30-degree angle. Your sine there, and I'm going to try and be consistent, would be a half, so I'm going to write 0.5. I'm not sharing my screen. I'm sorry. Fail. Sorry guys, there we go. That pi over 4 is your 45-degree angle. That's the root 2 over 2. So this is going to be 0.707. The pi over 3 is the 60-degree angle, is the 0.866. And then when you're at pi over 2, the sine there, the y value is 1. Okay, now these numbers are going to go back down, so it's kind of like a pattern to it. So this one is the 0.866. Then I'm going back down. You guys will see this better on the graph. 0.707. 5 pi over 6, the sine is 0.5. And then when you're at pi, you are back at 0. Okay, now as I go around the unit circle, now I would be on the bottom half of the unit circle, so these are all going to be negative. So this is going to be negative 0.5, then negative 0.707, then negative 0.866, and then 3 pi over 2 is that 270. Your y-coordinate there is negative 1. Okay, then we're going to kind of go back up. So this is going to be negative 0.866, negative 0.707, negative 0.5, and when you're all the way around the unit circle back at 2 pi, the y-coordinate is back to 0. All right, now, this was done, this lovely graph here, by Mrs. Gamble a million years ago, so it is perfectly spaced out, I guarantee you that. But they're not exactly, just kind of pay attention to where you're at in the coordinate plane here, but she's got the pi over 6, pi over 4, pi over 3. Then there's kind of like a little bit of a skip, so just kind of pay attention to that. This goes from 1 to negative 1, and then each of these marks as you go up the y-axis is a tenth. So the sine function always, let me grab a color so it's a little easier to see. Sine is going to start at the origin 0, 0. Okay, now I'm going to skip over like 2 spots to get to the pi over 6. At pi over 6, I'm at a half. So nice point for that one. Now the pi over 4 is that root 2 over 2, which as a decimal is that 0.707. So I usually just go to the 0.7 and then maybe just try to come a little bit above that. Doesn't have to be perfect. Pi over 3, you're at 0.866. So I go up to the 0.9 and then just back it off just a little bit. And then at pi over 2, now I'm going to skip over 2 spots here to get to the pi over 2. You're actually at 1, so that'll be at a nice number. And then you guys are going to see this. This is like starting to go around the circle, and now I'm going to come back down. So you're going to skip 2 spots. 2 pi over 3, you're at that 0.866. So I just kind of try to line it up with the other one I just graphed. 3 pi over 4, I'm at that 0.707. 5 pi over 6, that'll be a nice one, that's at 0.5. And then when you get back to pi, you are at 0. So basically what I've done here is recorded the y-coordinates of the top half of the circle, and now we're going to go back down. So I'm going to skip over 2 spots here. At the 7 pi over 6, I am at negative 1/2. And then 5 pi over 4, I'm at negative 0.707. And then at the 4 pi over 3, we are at negative 0.866. And then you're going to make sure you skip over 2 here. 3 pi over 2, you are at negative 1. Okay, now this is going to start to go back up towards the x-axis, but these same numbers. So, again, I just tried the negative 0.866 again. I'm just trying to line it up with my other one. 0.707, I just try to line up with the other one. The 1/2 will be right on a grid mark. And then when you're at 2 pi, we're back at 0. And I'm just going to grab my highlighter here so you guys could see this. And then, if we had more space, we could repeat this pattern and go around the circle again. And this makes what we call a sine wave. So technically it doesn't stop there, so let me just put a little arrow on the end. But this repeats. So that we call, like I said, we call it a wave, and it would just repeat. So that would be a full example of one period of a sine wave. So you guys will get some definitions here in a second. Does anybody have a question? Okay, now I'm going to have us do the cosine wave. And let me slide this up just a teensy bit here. Maybe do something for me here real quick. The negative sign is not on the 1 there, just on the y-axis. This is going to be the same concept, same numbers, but instead of doing the sine, I'm going to do the cosine of the angle. So here, your x-coordinate is going to represent whatever angle measure you're working with in radians, and the y-coordinate is going to represent the cosine. And I'm not trying to confuse anybody, but if you're looking at the unit circle, the cosine of that angle is actually going to be the x-coordinate of the point, but it'll be the y-coordinate of the point as we graph this in the coordinate plane. Okay, now this one starts in a different spot. If you guys are looking at your lovely unit circle, let me grab mine here real quick. If I start at 0 for my angle measure, the cosine here is 1. All right, so I'm doing the x-coordinates as I do the cosine. So this is actually going to start at 1. And then as I go around the circle, this is root 3 over 2, which is the 0.866. And then this guy's the 0.707, 0.1, or 0.5, I don't know why I was going to say 0.1/2, 0.5. Pi over 2, you are having a cosine that would be 0. And then it's going to kind of repeat, but this is going to go negative right away, all right? Because if you look at your x-coordinates around your unit circle, that first quadrant, they're all positive. The second quadrant, then, they're negative. So this next one is negative 0.5, negative 0.707, negative 0.866, and then when you're back to pi, the cosine there is negative 1. Okay, then these guys are going to kind of go back up. So this is going to be negative 0.866, negative 0.707, negative 0.5, and then, sorry, when you're at 3 pi over 2, that would be your 270 degree. The x-coordinate there is 0. Okay, then, when you get into the fourth quadrant, if you guys are looking at your unit circle, the fourth quadrant, when you go there, then the x values become positive again. So this is positive 0.5, positive 0.707, positive 0.866, and then back to 2 pi, your cosine all the way around the circle is back at 1. So this is going to be similar to what we just graphed, but it's basically going to be shifted back. So instead of starting at 0, 0, whenever you have a cosine function, that's going to start at 1. Okay, now all I'm going to do is the same thing I just did before. Now this only labels the pi over 4s, but the marks are on the graph. So that first mark there is pi over 6, pi over 4, pi over 3 would be the next one. So just kind of pay attention to that, and it should follow the table exactly. So that 0.866, I'm just going to go a little bit below the 0.9, 0.707, just a little bit above the 0.7, and then pi over 3, we're going to be at a 0.5, and then at pi over 2, we are at 0. Then you're going to see it dip below the x-axis. Now, this one you skip over 2 spots on your x-axis as you go because of the way this is spaced. But the next one here would be at 0.5. And then I'm at negative, let's see, 0.70767, so in here. The next one you're at negative 0.866. Kind of right in there. And then you're going to skip over 2 spots the way this is spaced. And at pi, you are at negative 1. And then we're going to come back up. So skip over 2 spots on the x. The next one you're going to be at that 0.866. The next one you're going to be at that 0.707. Then you're going to be right on a nice mark at 0.5. And then that 3 pi over 2, you're back at 0. And then just the last piece of this just goes back above the y-axis. So it skips 2 spots from that 3 pi over 2. And then you're going to be up at a half, which will be on a nice mark. 7 pi over 4 is that 0.707. Then I'm at the 0.866. Then I just skip over 2 spots to get to the 2 pi, and then you're back at 1. So this one is the cosine wave. And I'm just trying my best to kind of connect this up. Okay, this is what we would call one period of the cosine function. And again, this, I'm going to put a little arrow on the end of both ends of this. This would continue. We could keep going around the circle and keep generating these points. You could also go around the circle clockwise, and that would generate the negative side of this, and so it continues to make this wave. And so that's what we're going to work on today in our notes. Is anybody